All right, let's get started. Good afternoon, everyone. My name is Amitabh Tamhin. I'm a program manager with the Failover cluster team. Welcome to the session. I would be speaking about cluster networking essentials. So when you deploy clusters, you have these questions that how many networks do I need? How many NICs do I need on my server box so that I can create a proper failover cluster? Once you decide on the workload you want to deploy on the clusters, then if it's a Hyper-V cluster, how many networks do I need, especially when you consider live migration, VM guest management, and things like that. So those are some of the questions I'm going to cover as part of this session. Most of the content here really is kind of spread out in different blogs as well as TechNet articles. So this is an attempt to incorporate all the networking that affects clustering in this deck. Most of the content actually is applicable from Windows Server 2008 onwards. So 2008 R2, Server 12, as well as the new Server 12 R2. The new features introduced in Windows Server 2012, I will be calling those out, and it's kind of sprinkled throughout the deck. So there are some references more towards the virtualization and Hyper-V in general, but all the content is applicable to file server clusters as well as SQL, Exchange, DAGs. The way I have organized the deck is I'll start with the cluster networking basics, like what does networking mean for clustering in general, and then some of the guidance around networking considerations, like how many networks and things like that. Then we'll take a slight deep dive into the core of the cluster networking architecture. And feel free to ask questions at any point of time. So I'm open to, and I'll also be available after the session for questions. But anytime if you have questions, just ask. And then I would go into some of the configuration tweaks and knobs, or some of the configuration choices that you have as part of the deck. And lastly, the multi-subnet clusters, which is typically your multi-data center stretch cluster scenarios. And I will be talking about the networking considerations for that. So let's get started. There's a lot of content, so I would be keeping up a little faster pace. Cluster basically is a distributed synchronous system. So all the state is actually replicated to all nodes in the cluster. So for any change you make in the configuration or the role placement, it gets replicated to all nodes. So to achieve that synchronous replication, we actually have the requirement that all nodes be talking to each other. And so that's where we actually have underneath a full mesh connectivity with all nodes in your cluster. So if you have 8 nodes in your cluster, all 8 nodes are talking to each other. The messaging underneath is basically unicast, and all the cluster communication happens on port 3343. And I'll be going a lot deeper than that in the architecture section, but TCP and UDP protocols over port 3343. So when you're creating the cluster for the first time, all nodes come up and they start to look up for other nodes in the list, and then they form routes and create the cluster. So cluster networking in general the traffic that cluster generates can be classified into 3 big buckets. The first one is the health monitoring for the nodes, which is cluster heart beating, which cluster checks whether all other nodes are alive. The next one is intra-cluster synchronization, which means that's the bulk of the heavy lifting for the state replication. And lastly, if you're using cluster shared volumes, the I/O considerations for that, that's the third bucket. So let's look at the heartbeat. Heartbeat is basically every node, since it already has a communication path to every other node as part of the full mesh, it heartbeats to every other node. So all other nodes. So each node goes saying, are you there? The other node has to reply saying, yes, I'm alive, and by the way, are you there? And then this guy has to respond. And so it's a handshake that happens between all nodes in the cluster. And it's by default, out of the box, when you create a cluster, the heartbeats are sent every second. So if a node misses a heartbeat, we have a built-in threshold, which is again a default of 5 missed heartbeats. So beyond 5 missed heartbeats, which means once per second is 5 heartbeats or 5 seconds, the cluster would consider a particular node as down, and then it would take down the applications that are hosted on that node. And so 5 seconds, you can imagine, is like the out-of-the-box default. Of course, you can change all of that, and under what's the rationale to change it, that I will be covering those in the slides later. One thing I should call out is when cluster starts up, when it does a full mesh connectivity, it figures out what are different route paths between nodes. And so it identifies a set of cluster networks. So if you go to Failover Cluster Manager UI, in the network section, you would see a bunch of cluster networks. And the heartbeats are actually sent on all networks. So that's the way cluster ensures that the networks that it has recognized as a connectivity path are actually available. So that's just an example. If I have a 2-node cluster, I have a public network where my clients can connect to, and I have a private network. So heartbeats are sent on all networks. In terms of network usage for heartbeats, it's actually fairly light. It's extremely lightweight packet, but it's sent at a once per second frequency. And all cluster networks. So bandwidth as such is not a factor, but the quality of service is actually a big deal in terms of the cluster traffic. We have seen cases where, like in production cluster, the data center had like 2 big routers to back each other up, and one of the routers actually went down. And so all the traffic of that data center was being funneled through a router, but that got overloaded, and it started to drop packets. And so it dropped enough packets to cross the 5-second threshold between 2 nodes, and then cluster nodes started to leave the active membership. And so ensuring the quality of service for your heartbeat traffic is important. And as long as one heartbeat on a network is accessible, the node is considered up. So it's not like if a network is down, the node is considered down. So if you have multiple redundant networks, that's always a good thing. So in the next bucket, which is the replication of information or intra-cluster synchronization, cluster underneath really has a cluster database. This database is replicated to all nodes. If you look deeper, it's actually a registry hive that's built on top of the local nodes registry, and the cluster has a lightweight replication mechanism on top. But it's a distributed synchronous system, so all state goes to all nodes. And so every other node, all nodes have to acknowledge and update. So that traffic is what affects the intra-cluster synchronization. So every time you configure a role, or if you start a role or stop a role, and if it changes ownership from one node to the other, that information is recorded in this replicated cluster database, and that generates some amount of traffic. And so this particular intra-cluster synchronization traffic is actually sent on the highest priority or the lowest cost network which is only one. So if you have a public and a private network, it gets sent only on the private network. And so cluster has the smarts to figure out which is a private network, what's the traffic, which is the most available for sending the cluster traffic. So that is built in. So in terms of network usage, it's again fairly lightweight. It's a small packet, but it changes. It goes to all nodes, and on a steady state, when cluster is up and running, depending on workload, it may or may not affect the high traffic. So for example, if you have scale-out file server or Hyper-V workloads deployed, or a traditional file server, the cluster updates are fairly rare on a steady state runtime cluster. So the cluster database replication happens less frequently. But if you have SQL clusters or Exchange clusters, they store the Exchange replication, or in case of SQL, the always-on replication metadata in the cluster database, and they use it as a replicated store. As part of that replicated store, there is some traffic that is generated. And so on SQL clusters as well as Exchange clusters, there would be some amount of traffic. But it's lightweight, but there is traffic. So again, because it's lightweight, bandwidth's not really a factor, but quality of service is. Just ensuring it reaches to the other nodes fast, and it's acknowledged by other nodes fast. Because let's say a scenario where you deploy a stretch cluster, and so now I have my nodes across the WAN, now the WAN has a latency. So because the state is replicated, all nodes have to acknowledge, and so the cluster would run at the slowest speed of the WAN link. And so if applications require this state to be replicated, the application performance may potentially get affected because of this. There is a feature that we are introducing in Windows Server 2012 R2, which is asynchronous cluster database updates, where cluster can replicate to a majority of the nodes, and that addresses some of this WAN link latency issues. But that's just a side note apart from the networking point of view. So the last bucket, which is the CSV, or cluster shared volume I/O, for cluster shared volumes, what it is actually it's a proxy file system, and it provides read-write access to the particular volume on all nodes in the cluster. And so any file open that happens on cluster shared volume, the metadata file for the file open has to be sent to the actual owner. Well, one of the nodes is marked as the owner, which is the CSV resource. So the metadata of the file open is actually sent to the CSV owner. But once the file's opened, the actual read-write access happens locally as long as the disk is connected. And so the metadata I/O, again, the bandwidth is not important, but it has to have a good quality of service so that it can open files faster. But what happens when a node loses the disk connectivity, or it simply doesn't have the disk connectivity? In that case, all the I/O of that volume is sent over the network to the CSV owner. And so that actually generates a good amount of traffic on the network, and that actually has some bandwidth considerations that you have to factor out. Underneath, I would be talking about detailed about the SMB multi-channel, but CSV uses SMB multi-channel, so there are all the advantages of SMB multi-channel kind of come with for CSV traffic. So that's just an example where I have 3-node cluster. The cluster shared volume the file is accessible on all 3 nodes. All 3 nodes have disk access, and only the lightweight metadata are sent to node 1 in this case. But the I/O happens locally. And when the disk connectivity actually fails here, the workload running is agnostic to the disk connectivity failure, that's the big advantage of cluster shared volumes, because underneath it sends all the I/O to the appropriate owner node, and the VM happily starts running. But from a network configuration point of view, that's a heavy traffic. So we talked about the two types, where the metadata as well as the actual I/O. For metadata, the bandwidth's not important, but for the I/O being sent over the wire, you have to ensure there is sufficient bandwidth so that your cluster heartbeat traffic or intra-cluster synchronization traffic can still go through on those networks. So with that, let me just jump into the networking considerations. So traditionally, for a long time, the guidance in terms of cluster network configuration was simple. You have two networks so that it gives you redundancy, and one of the networks is for your client access, and one of the networks is for the cluster infrastructure traffic, which is the three buckets that I just talked about. And so the cluster supports Hyper-V, the cluster supports IPv6 as well as IPv4. Cluster prefers IPv6 for the private network traffic. So especially when you're sending like a cluster database replication messages or heartbeat messages, it would prefer a IPv6 packet if you have that enabled. If you have IPv4, that's fine too, or a combination of that is also fine. For client access, however, again, we support both v4 as well as v6. However, the private autonet addresses are not supported, which is the IPv4 autonet addresses are not supported for clustering in general. But the IPv6 link local addresses on the private network are very much encouraged, and its cluster works on top of it just fine. So just on a side note, the way cluster identifies a public versus a private network is simple, which is if you have a public gateway configured on that particular network, it's considered public. If you don't have a gateway configured, by default out of the box, cluster considered it a private network. And so in terms of priority given to the cluster traffic, it prefers a network that does not have an outbound public access, so that it assumes it as an infrastructure network. And I would be going about, in a few slides down, I'll be talking about the converged networking model that's cluster now supports. So from a clustering standpoint, the guidance has been, I have two networks, one is public, one's private. But then if you go to talk to Hyper-V, Hyper-V's point of view, guidance would be you have one dedicated network for your host management, you have one dedicated network for your client access to the VM guest, and one network for live migrations. If you are configuring iSCSI as the storage backend, then you're talking about an iSCSI network on top of this. And so together, it becomes quite a big list of networks to actually configure. So, and sometimes you may not even have those many PCI slots on the servers. So the guidance is keep the quality of service good for cluster traffic. You may have like two 10 GB NICs, and you may NIC team them and carve out VLANs on top, or you can do all of that fancy stuff. It would work great. Just ensure quality of service for cluster traffic. Factor out the bandwidth for cluster shared volumes. The bandwidth usage for live migration would again be high when the VMs are actually live migrating. But the bandwidth for live migration may not be used at all if there are no VMs which are being live migrated. So yes, we recognize there is this guidance across multiple teams, but the point is quality of service. So while we are discussing this public and private network, the question is this really required? And as called out, it's really not an absolute requirement, but it's strongly encouraged. There are two basic things. One is the quality of service, and other is not to have single points of failure. So if you have one network, if that network's down, the node would be considered down, and the applications hosted on top would experience downtime. And so you don't want that. You actually want, if you have two networks, if one of them goes down, the heartbeats are still available on the second network, and the cluster is happily running. So there's always goodness to have a more than one path for cluster traffic. Especially if you have the NIC teaming configured underneath, let's say, and it exposes one virtual adapter, and cluster recognizes it as only one network. So when you run validate, it would actually flag a warning, because validate, that's a note to myself saying, okay, we have to improve that functionality later, but we need next. But the validate does not recognize NIC theming that you have configured on the virtual adapter. So that's where it gives a correct warning saying, I'm seeing only one network. And so, but warning is all, of course, it's something that you should consider seriously, but does not affect your support statement. And so that's good. So converged networking model. So I already talked about a few things like NIC theming, or you can have multiple NICs that are configured on different subnets, and both of those would give you the built-in resiliency for failures. So if the NIC goes down, you have the other NIC to actually talk to. If there is a NIC theming, the NIC theming driver already has the load balancing built in. On the quality of service side, you may actually carve out VLANs, or in Windows Server 2012, the networking team actually introduced this various QoS policies. So you may consider giving QoS policies as a way to ensure quality of service. So in terms of reducing single points of failure at a high level, it's like have more than one NIC. Ensure those NICs are actually configured on two different subnets. If you are configuring them on same subnet, then it's best recommended to have NIC theming. And I will talk about why why that requirement is there, because cluster does not recognize two NICs, or cluster ignores one of the NICs if you have two NICs on the same subnet. And so that's something to consider. So if you have two NICs on same subnet, simply go with NIC theming, or just have two NICs on two different subnets. So cluster can recognize those as two different networks. In terms of single points of failure, we have seen cases where all the redundancy is built into the physical network, but there is a problem with the NIC driver. And now, since both the NICs are actually of the same manufacturer in the server, that may potentially cause a problem. So that's a factor to consider if you to have two different NICs of two different manufacturers, just to give a complete end-to-end software stack for independence, to reducing single points of failure. And not just from a single box point of view, but also your upstream traffic have more than one switches as well as more than one routers. Of course, some of the networking experts here might have more ideas about it. So I talked about NIC theming in general, but SMB multi-channel has the awareness of the different cluster networks that are configured on a node. So SMB multi-channel knows that the cluster, it's running on a clustered node, and it has a set of private networks, and it uses that private networks to actually stream the CSV/IO traffic. And so cluster configures SMB multi-channel, and SMB multi-channel uses the private networks that cluster has recognized for sending the traffic. And in terms of live migration, again, for live migration, and I will be speaking about that in later, but the Hyper-V live migration is aware of the fact that it's running on a clustered node, and it has the awareness for the private networks and public networks that we just talked about. So in terms of networking considerations for cluster shared volumes, it uses SMB for communicating between nodes. So ensuring SMB services, as well, the SMB server service and the corresponding services are enabled is important. As CSV uses NTLM for authentication, and so NTLM needs to be enabled. NTLM v2 is fine. SMB multi-channel has the advantages for RDMA as well as NIC teaming, and so all that traffic actually, all that benefits are applicable, and they come for, they just work seamlessly for cluster shared volume traffic. In terms of tuning for CSV performance, we have seen disabling net bias actually to improve cluster shared volume traffic performance. The same is not true, or I would say we have not seen any big advantage of disabling jumbo frames, of enabling jumbo frames, but it's not exactly discouraged. So having, let's say if SMB multi-channel works better with jumbo frames, then it's okay to have jumbo frames enabled for your CSV traffic. And TCP offload as well as receive side scaling, they just work just fine for cluster shared volumes. So with that, let me just jump into the architecture deep dive for cluster networking. So there is this virtual adapter called NetFT, and so it's a cluster networking fault tolerance adapter, and this NetFT adapter actually provides has the intelligence to build the routes between the nodes in the cluster, as well as it sends heartbeats on those routes between the nodes in the cluster. So this NetFT adapter gets installed when you install failover clustering, so there is no specific configuration that's necessary for this. However, what it does is it has a list of physical adapters that are enabled for cluster use. It builds different routes, and it actually sends heartbeats, as well as if the particular network is down, it can send the cluster traffic, like in your cluster database replication traffic, over a different route. So it has that fault tolerance capability built in. So kind of a simplistic viewpoint can be that this is a cluster's internal NIC teaming driver. It doesn't exactly do load balancing, but it really has a fault tolerance capability. And there is a priority for the network. So in terms of the cost, as well as in terms of private and public, so this NetFT virtual adapter actually has the awareness of that priority. So when sending cluster traffic, the cluster traffic is sent on appropriate networks. To view this NetFT adapter, you can view this in Device Manager as well as in the command shell. So for the Device Manager, you may have to actually select like Show Hidden Devices, and then you would see the Microsoft Failover Cluster Virtual Adapter. If you use ipconfig/all, you would see the Microsoft NetFT adapter as well. What you may notice here is actually it has its own virtual MAC address. So it does work as a virtual adapter, and it has the IPv6 link local addresses that are configured automatically. So there is no configuration necessary. This is all happens when you enable or when you install failover clustering. So the one condition is that we have seen issues where admin installs failover clustering, netft gets loaded, that netft generates a MAC address, which is a virtual MAC address, and then you sysprep this OS image, you install this OS image on other nodes, and then you get a problem of duplicate MAC address detection. And so we addressed that problem in Windows Server 2012. So in Windows Server 2012, if you sysprep this OS images with failover clustering installed, netft has the smarts to recognize the duplicate address, and it generates a new address so that the communication happens just fine. So the next component that plays a big role in cluster networking is a network topology manager. This is actually not exactly a separate component because it's part of cluster service, but it does the heavy lifting of really identifying what are the different adapters, what are the different IP addresses of this node as well as other nodes in the cluster. And so it identifies what's the matching subnet, and so that's the same subnet route and that's a cross subnet route. And so that actual intelligence of cluster route built up is actually done by this component. And once it recognizes a particular route, like IP1 of node 1 talking to IP2 of node 2, it actually plumbs that route on netft. So netft receives this plumbing information from cluster service, and once it receives this information, it starts heartbeating on that route. So if I have a NIC1 that has IP1, and on the second node I have an IP2, netft would say, okay, send heartbeats on IP1 over port 3343 destined to IP2 again for port 3343. And again, this is a component that's part of cluster service, no extra configuration necessary for this. So in terms of the stack, you have the netft kind of plugs in as a mini port adapter, a virtual adapter. So it presents itself just like a NIC. And so when cluster service runs on top and it sends a TCP connection and uses the netft adapter for sending this traffic. So what cluster service says is, I want to talk to node 5, and I have the IP address of the netft adapter of node 5, and so it opens a TCP connection using port 3343 destined to the IP address of the node 5's netft. And so cluster sends it, and that TCP connection goes to netft traffic, and netft wraps it in a UDP header with port 3343 and actually sends that packet to the node 5 or the destination node. On the destination node, the UDP wrapped TCP packet is received by the netft adapter, and netft then unwraps the UDP header and sends the TCP packet up the stack to the cluster service. So that's how the cluster service establishes a TCP connection between the two nodes. But on the wire, you would see only UDP traffic. So in Windows Server 2012, we introduced a Microsoft Virtual Adapter Performance Filter. If you open up the properties of the netft, you would see the Microsoft Failover Cluster Virtual Adapter Performance Filter. What the job of this filter is to actually optimize the inbound traffic. Because the packet on the wire is a UDP, that's UDP packet that underneath has a payload of TCP. So this performance filter, what it does is instead of crossing the network stack twice, the end is stacked twice, it actually sends directly to the NetFT, and NetFT sends it to the cluster service. So your traffic doesn't cross the network stack twice. And that actually has a good amount of performance improvement for cluster traffic, including cluster shared volumes. This performance filter in Windows Server 2012 has been enabled by default. And so again, no configuration necessary for this. So just a quick note in terms of how cluster identifies these different networks. So let's say I have two NICs that are on the same subnet. Cluster topology manager enumerates these lists of NICs. It enumerates list of IP addresses. It identifies that both these NICs are actually on the same subnet, but cluster chooses to use only one IP on one of the NICs. And it would actually ignore the second NIC that has a IP configured on the same subnet, as long as there is another IP available. And so that's where configuring NIC teaming is important if you have two NICs that are on the same subnet. In terms of physical adapters, the cluster network that you see in the Failover Cluster Manager UI, that network has a adapter that's on each node that can access that particular network. And this adapter, which is a physical NIC, can be part of exactly one cluster network. So you can't have more than one cluster network using only one physical NIC. So that's just an example where I have those two NICs and cluster only uses one of the NIC cards and it forms one cluster network. So in terms of cluster network roles, so that's the snippet of the Cluster Failover Manager UI. And you see a list of roles or network roles with the associated adapters as well as the IP address. For this network, if you open up the properties, you would see it's actually a role assigned to this cluster network. And that role can take one of these three values, where a value of 0 indicates this particular cluster network is disabled for cluster use, especially something like your iSCSI network. For iSCSI network, cluster today automatically disables it for cluster use. And so it only picks up the networks which are not assigned to the iSCSI adapter. If on a network, a value of 1 indicates it's actually enabled for cluster communication only. It's not routable, or even if it's routable, if you set a manual configuration value of 1, cluster would use it only for infrastructure traffic. So this is mainly for your UI tools as well as your PowerShell, where it won't configure IP addresses on those networks for your client roles. And a value of 3 is actually, it's enabled for both client as well as cluster communication. So I briefly mentioned about cluster network prioritization. So cluster has, every network that it builds has this metric value. You can consider the metric value as equal to a cost of the network. The higher the cost, the lower the priority of cluster to send the traffic on that node, on that network. And so if it's a private network, meaning if it's non-routable, it doesn't have a default gateway configured, cluster gives a lower cost to it, and the lower the cost, the higher the priority. And NetFT uses this priority to send the cluster traffic. So your intra-cluster synchronization I/O as well as your metadata I/O would be using this highest priority network, which is the lowest cost. So a network role of 1 would have a starting value of 40,000, which is your private network, and lower. A network role of 3, which is your public network, would have a starting value of 80,000 and lower. And so that's by default, the private networks are preferred for sending cluster traffic using this matrix calculation. Again, this is configurable. In the configuration section, I will go over how to configure this. Again, this is by default configured by cluster service. So you don't actually have to tweak anything. But if you have a need to control, fine-tune this, you can do that using cluster properties. And one thing I should call out, and that is so cluster has the smarts to understand if a particular NIC has RDMA enabled, or whether it's RDMA capable. If it's RDMA capable, cluster gives it a lower cost. That means even higher priority. If cluster has a NIC teaming awareness built in, and so NIC teaming would get the next highest priority. And if it's a 10 GB NIC, which is faster than a 1 GB NIC, the 10 GB NIC would get a higher priority or lower metric value. And so that way, cluster knows how to stream the traffic. Within the metric values, if you set it in such a way that if the metric values are actually less than 16 numeric value apart, then NetFT can load balance cluster traffic across those multiple cluster networks, which are kind of a difference of not more than 16 net metric values. And that's just a partial example of how to view the value. You have this automatric, which is set to true by default, and the metric value is actually seen here. So SMB with multi-channel. So I talked about CSV uses SMB for its node-to-node communication. So your metadata as well as your all I/O when the storage connectivity is lost on that node, all I/O is being sent over the wire. Cluster shared volume uses SMB to send that traffic. So SMB has the multi-channel where let's say if I have 2 or 3 cluster private networks and a couple of public networks, cluster service picks up those private networks, configures SMB multi-channel to say that, okay, go ahead, use these networks, and SMB multi-channel sends traffic or distributes that I/O over those 3 private networks, or how many private networks you may have. SMB multi-channel again has the RDMA capability as well as the NIC teaming awareness, as well as the speed of the NIC awareness. So it prefers to send traffic over RDMA NICs, then NIC team NICs, as well as then the higher speed. If SMB multi-channel is not available, the CSV I/O that is still being sent over SMB uses NetFT to send the traffic. So the same path or the same network prioritization that I just talked about would be used for cluster shared volumes if you disable SMB multi-channel. It's not recommended. SMB multi-channel is enabled by default, but should you find a need to disable SMB multi-channel, then the CSV I/O would be sent over NetFT, which has its own prioritization logic. So I briefly talked about the logic for preference of the networks where SMB multi-channel would be configured by cluster service to use private networks. If you want, by default, cluster only configures private networks for SMB multi-channel use. If you want to configure client public networks for SMB multi-channel, then you have this property that you can set to true or value of 1, which is a true, to actually, then the cluster would pick up public networks along with the private networks and configure SMB multi-channel to use all these networks. And SMB multi-channel then use the RDMA capability, NIC teaming, the speed of the NIC, all that prioritization, and stream the traffic for cluster shared volumes. So jumping on to network validation, I mentioned that network validation does not have the awareness of nick timing. However, we did improve one important piece in Windows Server 2012 R2, where network validation actually uses port 3343 and netFT to actually validate whether the nodes have connectivity enabled for the cluster. Before, it used to use only ping, and so let's say a firewall rule has blocked port 3343 for a particular communication, and only it affects a node. The ping works just fine, and you would think that the network connectivity is present on all nodes. And when you try to add that node, or when you try to create a cluster, you would start to hit issues. So this is a kind of fairly important step towards finding out issues early. So you still have to enable the port 3343, but this is network validation now actually helps you find those issues. So in terms of this slide, I actually wanted to just highlight a particular problem where we have seen a lot of issues crop up, where I have an existing cluster, I'm trying to add this node, and my PowerShell waits for 3 minutes, nothing happens, and I get a timeout error. So underneath, if the add node can fail for many reasons, like you may have Active Directory permissions issues or whatnot, but from a networking point of view, cluster is a distributed synchronous system. So it requires full mesh connectivity between nodes. So the joining node that's trying to add itself to the cluster, it has to first establish network communication to all nodes that are actually active in this cluster. And so if, let's say I have 4 nodes in my cluster and I'm adding a 5th node, if that node is able to talk to 3 nodes in the cluster but not the 4th, the add node is going to fail. Hopefully the network validation improvements that we did should have flagged that out sooner, but if you do see add nodes failing because of network connectivity issues, so that's the requirement. The 2 things happen. First is cluster would always favor the nodes which are already in the cluster membership. And so the adding node won't disrupt the active cluster and the roles hosted. But the add node, the cluster service starts, it waits for a few minutes trying to establish communication. After a while, the cluster service on the node being added goes down because it's not able to talk to all nodes in the cluster. But the PowerShell experience here, or the add node UI wizard, would only give you a timeout error because it simply waits for the node to come up for 3 minutes, and actually the node, the cluster service started, but it couldn't form the communication full mesh, and then it went down. So in terms of configuration, so that was the networking deep dive from an architecture perspective. So in terms of configurations, when you install failover clustering, we install these firewall rules, a set of firewall rules. Those are all have the failover clusters star rules. Those are enabled by default. And so for Windows Firewall, you don't have to do any extra configuration. But if you're using third-party firewall firewall tools, then you may have to manually add these or enable these later. Again, from a configuration standpoint, it only affects third-party firewall. For Windows Firewall, it's actually enabled by default. So I talked about the cluster heartbeating between nodes as well as the cluster full mesh network connectivity. By default, out of the box, cluster sends heartbeats every once a second. The default threshold is like 5 seconds. But that's really from a point of view of, I want to identify issues as soon as possible. That's really to provide the highest levels of availability So now what happens is if a node actually goes down because it's powered off or it's bug checked, cluster service from a clustering point of view, we want to identify that condition as soon as possible. And then cluster goes ahead and figures out which are the nodes that are still part of the cluster. It places the roles that were owned by that node on different nodes. So that's the automatic availability capability of the clusters. However, at the end of the day, if your clients can reach your service, be it SQL or be it a virtual machine guest, if the clients can reach the service from a pure admin point of view, you should consider the node as up. And so because the default heartbeat threshold is 5 seconds, that kind of reduces the down. So we have seen cases where I'll actually give a good example. That is, there are some network. So a customer I was visiting, they had a network glitches that were showing up every some time in the network hardware architecture, and the cluster, because of the 5-second timeout, it flagged that issue and it kicked a node out and it placed those virtual machines on different nodes. So from the user or the customer point of view, it was my clients were connected to these virtual machines. After installing failover clustering, now my VMs experience downtime, and so isn't it counterproductive to what my intention was? And the short answer is, yes, it is counterproductive, but you have dials and knobs to increase those. But the punchline is, cluster is just a messenger. But you still have a networking issue that was causing 5-second outage where no traffic was sent for 5 seconds. But if you really want to, you can always tweak the defaults higher. And so that's where that scale where if you increase the defaults for heartbeat threshold, it would take that much longer for cluster to actually recognize the actual issues like a node being powered off or node bug checked, because those would take that much longer for cluster to take action. So there is that fine balance that you may have to actually configure. So in terms of properties, cluster has, or the cluster common properties, we have these 4, where the first is the delay, where that's the frequency in which the heartbeats are sent. Again, by default, it's 1 second. You can obviously increase it, but we strongly recommend not to increase the delay. But if you want to increase the node heartbeating thresholds, go ahead and increase the thresholds. So by default, same subnet is 5 seconds, and cross subnet is 10 seconds. And so cross subnet is when you have a stretch cluster scenario deployed where 2 nodes are in different subnets. So that's where the cross subnet comes in. So you should, if you want to improve if you want to reduce the sensitivity of cluster heartbeating, increase the threshold, not the delay. The PowerShell command is also listed on the slide if you want to change it. In terms of Windows Server 2012 R2, what we did is we actually increased the defaults for a Hyper-V as listed on this slide, where the same subnet threshold was bumped up from 5 to 10 seconds, and cross subnet was bumped up from 5 to 20 seconds. And so if I have a Hyper-V cluster deployed, my nodes would now, out of the box, take 10 seconds. You may ask me, is this a fair configuration even with Windows Server 2012 or Windows Server 2008 R2? I would say probably yes. You can actually increase the thresholds for Hyper-V. But for scale-out file server or traditional file server, you still want the aggressive detection of node health, because SMB has the automatic continuous availability or the load balancing capability built in. And so you want that capability to kick in and take care of the client connections instead of reducing cluster sensitivity to node failures. In terms of SQL clusters, as well as so for SQL clusters like always on or your FCI, we recommend the defaults out of the box be kept the same, but you can always increase that as per your need. For Exchange clusters, I believe since Exchange DAGs wrap cluster installation in their APIs, they do increase some of these defaults when they install Exchange on top of clusters. On a quick note, we made this improvement where the NetFT that actually does the hard beating, but cluster service running on top. So in the cluster service log, hopefully you may not have to actually look at it, but if you do have to, the cluster service log would only talk about, oh, I have this network and this network went down, or I have this network and this network got disconnected. But it won't give you a more detailed information, and that detailed information is actually present in the NetFT logging. So what we did is we actually capture the last few NetFT heartbeat logging information in the cluster log itself. So now you get a good inline view of what's really happening. And this property identifies the number of heartbeats, which is essentially back in time, how many heartbeats you want to capture in cluster log. Because the defaults have been 5 threshold or 5 heartbeats, this property default is 10. So last 10 heartbeat messages would be captured in the cluster log. The recommendation is if you increase the heartbeat threshold, then this property should be made basically double of your thresholds. I already talked about this already, but in terms of the network roles assigned, whether it's disabled for cluster use or enabled for cluster-only communication or client and cluster communication, all of that cluster takes care of for you automatically out of the box. If you really want to, you can configure it using both UI as well as PowerShell as shown in the slide. I talked about the network prioritization, so where the metric value is the cost, and the lower the cost, the higher the priority. And if you don't like the default, so again, by default, the priorities or the metric value is configured. If you want to change it, that's the way in which you can change it using the PowerShell. For your live migration network priority, and this is interesting, where live migration has the awareness that it's actually happening on a cluster node, and it is aware of the list of cluster networks, and it uses the second highest priority network. So the cluster traffic is sent over the highest priority network, and live migration is sent over the second highest priority network. And so that kind of gives a nice balance for cluster shared volume traffic as well as intra-cluster communication traffic and the live migration traffic. If you using UI, so this used to be available as part of the VM properties, but we changed it to the network. So if you right-click the cluster networks, you would see the live migration settings. Once you select it, you can change the priority in which cluster you want to use live migration to use a particular cluster network. Again, this by default, you may not have to, but this is a way in which you can fine-tune it if you want. So network binding order really affects your inbound traffic, or sorry, the outbound traffic on the node. And hopefully you may not even have to tweak this, but I will call out that NetFT, which is a virtual adapter, it binds itself as one of the lowest or in the binding order. And so when you send any, for all the IO, for the internet traffic that is outbound from a node, it by default the networking stack would not use the NetFT adapter unless you, because cluster service identifies that I want to use that NetFT adapter, hence the traffic is sent over NetFT adapter. In terms of, this is the QoS policies that were introduced in Windows Server 2012. One of the, from the set of QoS policies, the two I would like to highlight, and which is the the traffic prioritization and the bandwidth allocation. In terms of prioritization, it's always recommended to have the cluster traffic to be the highest priority so that the heartbeats can be sent with the highest priority, and that would ensure the roles, the cluster would not take down the nodes, and there is sufficient quality of service for the heartbeats, and the role that also increases the availability of the roles hosted on those nodes. In terms of bandwidth allocation, you have this relative minimum bandwidth property where you can say that I want to carve out maybe 30% for that network or 20% for live migration and things like that. So you may actually say cluster traffic always have an X amount of bandwidth, so it ensures quality of service available. And in scenarios where, or in failure scenarios where the node's connectivity is lost and the cluster shared volumes now starts funneling the I/O over the network, you can use this property to control the amount of bandwidth used by cluster shared volumes for the file system redirected, as well as live migration networks when they do use a whole lot of network bandwidth. iSCSI, again, by default, out of the box, cluster has the awareness and it disables it for cluster use. So no configuration kind of changes necessary here. And the iSCSI adapter is also lowest in the binding order for outbound traffic. So in terms of spanning clusters across subnets, so clusters do support nodes in different subnets. So this is especially true when you have multiple data centers and you're stretching clusters across your data centers. So a set of nodes are in one subnet and a set of nodes are in second subnet. So cluster has already built the same subnet cluster networks and cross subnet cluster networks. And so there are some interesting considerations to figure for this. I'll just highlight this, which is cluster shared volumes in Windows Server 2012 do support nodes in multi-subnet. That used to be not the case for Windows Server 2008 R2. Cluster nodes by themselves were already supported even in 2008 R2, but cluster shared volumes V1 was not. But in Windows Server 2012, it does. SQL Server 2012 also supports running on top of a cluster which is stretched across different subnets. So this is really affects how the heartbeats are sent over the wire. So you have these, let's say I have these two nodes, and or let's say I have three nodes where a node is in a different data center, which is my DR data center, and two nodes are in my primary site. So I have this network communication that is happening between the two nodes in the same data center. By default, cluster always heartbeats over the same subnet. So it doesn't really use the cross-subnet route to send heartbeat to a node that is in the same subnet by default. And so that's what really full mesh heartbeating or is talking about. So we have this property called as plumb all cross-subnet routes, which by default is 0, which is the cross subnet cluster won't send heartbeats if a same subnet network is available between the two nodes. However, if you can change to a value of 1 where cluster would heartbeat on all networks between the two nodes, even if the two nodes are in the same data center, they have the same subnet, but they also have a path using cross subnet, then cluster would also heartbeat across the cross subnet if you set the value of 1, which is the middle box there. The value of 2, which is something new that we introduced, is to tell the cluster service to stop identifying networks between two nodes if you already have a same subnet path. Which means, because by default, cluster would identify there is a cross subnet path between two nodes, but it simply won't heartbeat. But if you don't even want that traffic to happen, then you can set it to value 2, where cluster would heartbeat only between the same subnet, but not just that, it would stop identifying new routes between two nodes if you have same subnet route available. In terms of cross data center cluster deployments, from a quorum standpoint, a file share witness configuration is typically recommended. And this file share witness really, we have seen people asking questions where, oh, how do I ensure quality of service, and how do I get the best quality of service reachable for the file share witness? Because typically, the file share witness is configured on a third separate site. And the short answer is, you don't really have to go out of the way for configuring file share witness network from a networking standpoint. In terms of network usage, the only time cluster uses file share witness, does any network path or network I/O to file share witness, is when nodes join the cluster or nodes leave the cluster membership. And so that's when the file share witness gets updated. So on a running cluster, which is steady, no updates happen on file share witness. So there is no big configuration steps necessary for file share witness, and that's something I really wanted to call out. In terms of security, you have this security level property, which is again a cluster common property. So by default, it is value of 1, which means the packets sent on the wire are signed packets. If you want them encrypted, then you have to set this value to 2. But encryption of the cluster traffic has a performance, there is a small amount of performance degradation, but that's certainly available, and it may be necessary if you're doing cross subnet multi-data center stretch clusters. So that was really from a cluster's point of view. But what about client access? For client access, if you want the roles to fail over automatically across the data centers, you actually want to consider deploying in this model, where in this fashion, where you have these two IP address resources which are configured in a dependency, in an OR dependency to the network name resource. Excuse me. And Failover Cluster Manager you can do all this configuration in using Failover Cluster Manager or PowerShell. But the point is that IP address A can be mapped to subnet A when the role is running on the first data center. On the second data center, when the role fails over, the IP address 2 or IP address B would be running, or it's up and online. And so at any point of time, only one of these IP addresses is actually online. It certainly helps for automatic failover capabilities, but it does brings in some interesting considerations. And so basically, let's say I have my DNS server 1, and this is my DNS server 2, and my client is sitting here, and I have my two sites with two nodes, and the 10.10 IP address is actually online. That IP address gets recorded with the DNS server, and the DNS server then replicates to another DNS server instance. And when client communicates to the service, it actually, let's say, talks to DNS server 2, and so it gets the IP address, everything's happily running, that's good. But now when this role fails over, the second IP address would now come online. The 10.10 IP address is no longer reachable. The DNS replication again has to happen for it to be replicated to the second site. And then the record gets refreshed or updated on the client box. The challenge is for that duration, because the DNS replication may take some time. And the challenge is for that time, even though cluster has brought the service online on the other side, the client connectivity may be affected. So it's not exactly a solution per se, but we recommend to scale up. Basically, to have more than one node in your each data center, so that cluster can fail over locally first, and so your 10.10 IP address remains up and running, and the client connectivity is not affected. That's something, a minimum, and you can use preferred owners as the property to control this local failover behavior. If you really want to, you can configure VLAN, which is stretched across your data centers, and then the IP address for each configured for this on this VLAN can then be used for your client access. But that IP address doesn't change because it's a stretched VLAN, and your cluster as well as your client traffic is not affected. There are for example, from Cisco, I don't know if there is any other provider that actually has some similar capabilities, but you may have an abstraction network device where it provides an external IP address, but underneath it maps to more than one IP addresses. So I still have my 10.1 and 10.10 and 20.20, but both these IP addresses are registered with this device, and this device has now the intelligence to send the traffic sent for the external IP address to one of these two IP addresses. And that's Cisco does provide a similar device, but I don't know about any other provider. In terms of configuration, there is this register all IP providers property, which is by default not enabled. But when you set it to 1, what happens is cluster this 10.10 as well as 20.20, cluster registers both these IP addresses with the DNS. So when the replication happens, the client gets a list of IP addresses. But then it comes down to the intelligence in the client to talk to one of these two IP addresses. And so it's now supported. This form of access is supported in SQL Server 2012, but it requires smarts in the client application. Host record TTL, I'm pretty sure you're already familiar with this, but that's something you can consider for DNS record changes. For network virtualization, that's something Hyper-V now supports, where it's the NVGRE, that's the short form that many people actually use. The virtual machines get their own IP addresses for the guest, and so clients connect to that IP address, and underneath the virtual machines can fail over from one subnet to the other, and that is taken care of for you by the Hyper-V as well as System Center in this particular case. So it does require System Center 2012 SP1 for network virtualization in case of Hyper-V. So in review, so that's basically all I had. So in review, I want, at the end of the day, cluster service requires quality of service. That's the band I've been beating for the traffic, for the cluster traffic, the heartbeats, as well as intra-cluster synchronization, and cluster shared volumes. Cluster shared volumes uses SMB SMB underneath, so SMB multi-channel and its benefits work well for clusters. And I think the key point I want to highlight, most of it just works out of the box. You don't have to really configure a whole lot other than provisioning some of the basic networking infrastructure. But if you want to really tweak it, if you want to customize it to your needs, that's possible. And there's a lot of properties there that are available. So that's that. And in the appendix section, actually, I have a list of IP properties captured for your offline reading as well. So at this point, I would like to open up the session for questions. All right. Please do file evaluations. That we do appreciate your feedback. And thank you very much for attending.